Okay, sorry about that. The video, my phone ran out of room, so our video for 10.1 is going to be 2 parts. Sorry. So this is where it got cut off. So we were talking about anything to the first power is itself. So 16 to the first power is just 16. But if I've got this one, this is 16 to the first power with a negative, so this first power should be closer. Sorry about that. So this is saying 16 to the first power, and then the negative gets attached, so that's negative 16. This one is saying the negative's included. Still, it's negative 16. It's just when we have like an even exponent that will change the negative. But if we have a 0 power, remember anything to the 0 power is 1. We kind of talked about this on Thursday. If I have negative 16 to the 0 power, or as it should be read, 16 to the 0 power, the negative getting attached later, you've got to do 16 to the 0 power because this is immediately next to the 16, and this is not included in the 0 power. So it would be 1 with a negative in front. If I do include the negative to the 0 power, like on this one, oops, sorry, let me get down there. Like on this one, that one is, the negative is included to the 0 power. So anything at all to a 0 power is 1. Except for 0, but we're going to assume in everything that we do that we're not dealing with 0 to the 0 power. So anything at all to 0 power is 1. Okay, so this is where you can impress your friends. Okay, so if you want to write something super crazy, you can make up anything you want. So we could do like, here's a really crazy, square root of 3.72, which is going to be not pretty at all, minus 4/9, and we'll square all that, plus, oh, how about plus pi? That'll make it crazy. Plus pi. If I put all of that, oh, I'm going to do these kind of brackets now. All of that then, because it's all included in this, if I put that to the 0 power, so I've got all of this junk to a 0 power. Anything at all to a 0 power is 1. Because basically what you're saying is you're going to calculate all of this, get a number, but any number to a 0 power is 1. So anything, doesn't matter what we end up getting, to 0 power will be 1. And again, I'm sure we're not going to get a 0 in there, so that will be safe there. Okay, so this is kind of like some of the problems you'll be given. You'll have some decimals, some other numbers, and then they'll just be to the 0 power, to the 1, or to the first power, and then you just have to write what they are. You'll also be given like exponents, so if I have m to the 0 power, that is also 1. Oh, let me write my m a little better. That's 1. So if I have negative 17.3 to the 0 power, that's still 1. Anything to a 0 power is just 1. Okay, so this is how you can use that. You're going to be given some expressions in your homework, and we've done many problems like this before where they give you the expression, they tell you what the variable is equal to, and then you just have to do the plug it in, and figure it out. But our little 0 rule is going to save you some time if you catch it. So if you have, let's look at one we've got. 2x minus 9 to the 0 power, we're going to say x is 3. So in the past, we've plugged this in, done the math, figured it out, and then gotten our answer. But if you notice, this is just going to get plugged in. So I'm going to erase that for a minute. We're just plugging 3 in for x. But that's just going to give us a number. That'll spit out a number or a variable or anything. It doesn't matter because anything to a 0 power is going to give us 1. If we do the math in there and we get 7. So this is the nice thing. If you mess up and you get the wrong number, you're still going to get the right answer as long as you remember that that to the 0 power is 1. Okay? If we got 1,000 in there, if we did our math, granted that is totally wrong, but if we did our math and we got 0 or 1,000 to the 0 power, the answer still is going to be 1. So the point is, before you even start this problem, if you caught it, hopefully you looked at this and you said, oh, well, all of this is to the 0 power, so it doesn't matter what it is, so you just wrote 1 and didn't even do any work. So you can save yourself a lot of time if you pay attention. We'll have a couple other problems where the whole thing's not to the 0 power, just some of it, and so that will change things a little bit too. Let's look at one like that. So you'll have, say, t to the 0 power minus 4, whoops, semicolon, when t equals 7. So on this one, it doesn't matter what we plug in there because it's going to be 0, or not 0, 1, because we're raised to the 0 power. So this, no matter what we put there, will be 1. And then we just have to do 1 minus 4, which is negative 3. But if you didn't catch it and you plugged it in, then you'll do 7 to the 0 power minus 4. And then hopefully you remember that anything to a 0 power is 1. And then you'll get the right answer after that. So a few different kinds of problems there. You'll have some with the first power involved, so make sure that you're paying attention and remembering that to the first power it's itself, to the 0 power it is 1. I think that is all. I think we covered everything. I'm just trying to remember what I covered before the video ended and what I talked about after, because I did everything because I didn't notice. So I'm doing this all a second time, so it's hard to remember what I've said and what I on this video and what I'm just saying again. But I think that's it. So I'll just give you your homework and you'll be done. So this is 10.1. This is in the very back of your book. So it's 10.1. You're doing 3 through 63 multiples of 3. So again, 3, 6, 9, 12, 15, and on and on. And remember, you can always check to see if you're on the right one. So say I'm doing problem 43, and I look at it and I go, wait a minute, is that a multiple of 3? You add the digits. So 4 plus 3 is 7. 3 won't divide into 7. So I know that is not a problem I'm supposed to do. So I look and I go, well, maybe it was 42. Am I supposed to do 42? 4 plus 2 is 6. 3 will divide 6. So that is a problem I should be doing. And then it's just every third problem. So that's another way to count it. Good luck, and I will see you tomorrow in class. Hopefully you're watching this on Wednesday. And so I'll see you on Thursday, the 19th, March 19th. And good luck.